I want to explain how to name ionic compounds from cations that have different charges. For example, iron can have a +2 charge, or iron can have a +3 charge. This is usually the case for transition metals. So if you're looking at an ionic compound that the cation is a transition metal, then you got to think about how to name it from these different charges. Now there are going to be I'm going to look at two compounds, FeO and Fe2O3. So these are both ionic compounds formed from a metal and a nonmetal, or a cation and an anion. Okay, and but this iron can have two different charges, a +1 or a +3, +2 or +3. So looking at this, okay, if I'm going to name it, what I have to do, since I don't really know which iron it is, I need to look at what the charge is on the other part of the compound, which is going to be, in this case, oxygen. Now, oxygen almost always has a -2 charge. So if I look at that and say, okay, oxygen has a -2 charge, in this first one, if oxygen right here is a -2, that means the iron must be a +2. Because according to the crisscross method of putting that together, if I drop it down there and I drop it down there and then I reduce it back, I am going to end up with FeO. Now, since that iron had this +2 charge, the name of this compound becomes iron Roman numeral II oxide, where that Roman numeral II right there represents the charge on the cation. Now looking over at this other example, okay, oxygen's sitting here with a -2, and there are multiple ways you can think about this, but hopefully once you see that, okay, I realize what's going on here. With that crisscross, that 2 dropped down to there. The iron was Fe. Okay, so the 2 dropping down there. So in this case, the 3 was over here, and it kind of went back up to there. That must have been a compound formed from iron 3. Alright, because iron 3 and oxygen -2, if I put those two together, would give me the compound Fe2O3. Now, the name of this compound of iron is going to be iron 3 oxide. Now, it's important to remember that when you're naming ionic compounds, that Roman numeral designates the charge on the cation, not the relative number of atoms that make up that compound. Alright? So I'll do one more. This time I'll do an example with 2 copper compounds. In one case, we're going to use CuSO4. In the other case, it's going to be Cu2SO4. Now, copper is a transition element. Okay, midsection of the periodic table, it can have multiple charges. So in order to name these, I have to figure out which one is which. The only way to do that is to look at the anion. Try to figure out what that anion charge is. Well, sulfate, if I look at my chart, has a -2 charge. So both of these are -2. SO4 -2. Now, comparing what's going on, if that's a -2. The sulfate here and the copper I'm looking at go together in a 1:1 ratio. The copper, the copper must be a +2, because when I put those back together, Cu, the +2 right there drops down to there for the SO4, and the -2 crosses across there. 2 and 2 reduces back to CuSO4. I'm just sort of going around in circles, but the point is, check it. It all will work. The name of this compound then will be copper 2 sulfate. Sulfate being the name of the polyatomic ion. Now over on the other side, okay, if the sulfate is a -2 charge, and I happen to have 2 of them in that formula, this copper must be a +1 charge, because when I put them together, Cu is a plus, SO4 is a -2, that plus drops down to there, this 2 comes back over there, I end up with the compound Cu2SO4. The name of this compound will be copper 1 sulfate. Okay? Running out of room there.